Okay, and welcome to another exciting Java class. In our last exciting Java class, we did a little financial data mining. And what we discovered was a way in which to extract data from the Google summary data. And I thought, wow, how exciting is that? But it was quite limited, and there were certain things you couldn't get. For example, you were probably challenged when it came time to getting the volume. Rhodey, did you get the volume? No. Rich, were you able to get the volume? Oh, with Yahoo Finance, and you got Yahoo Finance to work. You did? Wow.
It's a little slow if you do a bunch all at once.
It's slow.
If you do a whole bunch at once.
Oh. Well, I got a way to make it fast and to get way more data than you were getting from before. And so what I thought I'd do is give you the bird's eye lowdown on the financial data caper, whatever that means. And so first thing I want to do is say, that there's a whole bunch of what I will call summary data. And summary data, if you look at it, has a lot of interesting stuff in it, like the days range, the 52-week range, the volume, the average over a 3-month period, the market capitalization. Let me stop myself right there. What's market capitalization? What is that? Anybody sort of stock market savvy enough to know about that? Market cap? Market cap is the total number of shares outstanding times the number of dollars per share that they're able to get in the free market. So what they're doing is they're saying this is how the market has capitalized the company. I beg your pardon? Yeah, you could say it is a market estimate of the company's value. But in fact, value is in the eye of the beholder. And some people might say the market has undervalued the company. And the trick with trying to spot undervalued companies is what good investors who are value-oriented investors like Warren Buffett do all the time. So if you think about it, there are interesting and wonderful ways in which we can measure the value. So for example, if somebody says, gee, Apple is $532 a share, that's expensive. Well, is it? Relative to its value, the rate at which it grows, the earnings that it makes per share, the number of percentage points it has in its dividend, these are the things that actually allow us to compute the value for a stock. And if a stock has a certain growth rate, even a relatively high growth rate, we can still say, aha, we can get a reasonably high value out of it because growth-oriented investors will pay it. So if you think about value in a stock, it's really good to know what the growth rate is. And here is this summary in here, and it gives us everything but the growth rate. However, if we click on key statistics, we get even more information. And one of the things you look at when you see the information is you can see the PEG ratio expected over 5 years. And here they're saying the PEG ratio is 0.63. So what that's saying is the price to earnings ratio, that is the price of the stock per share divided by the number of dollars that it makes per share, which is called the price to earnings ratio, then divided in turn by the growth rate, gives us what's known as the PEG ratio. And people care about the PEG ratio because it is a measure that allows us to determine if a stock is under or overvalued. Most people claim that if the stock has a PEG ratio of under 1, it's considered undervalued. But people do other things as well. They compensate for the PEG ratio with a dividend. If during that time when it's growing it pays a dividend, they decrease the PEG ratio by a percentage in the dividend. And so now all of a sudden you have another way to revalue the stock based on the fact that it's continuing to pay a dividend while he's earning some sort of money per share. And the dividend is one of those things that you should be able to find with relative ease in the summary. And there it is. He's paying $12.20 a share. So I don't have to do anything. I can just buy a share of Apple stock for $533, and he's going to be paying me more than a treasury bond, right? He'll be paying me 2.3% per share. That's pretty good. So then I wondered to myself, how do I gain access to all of this wonderful data and put it inside of a data structure in my Java program? Because if I can do that, I can screen scrape this HTML data and somehow transmogrify it into data upon which I can do computation, right? Because how can I compute the PEGI ratio, that's the price to earnings ratio, divided by the growth minus plus the yield, the PEGI ratio, without being able to go through and extract this data? So, to answer my own question, here's the PEG ratio, 0.63, and it's coming out. It's coming out of my little program. So I'm extracting this data directly from the Yahoo Finance page, and I even disclose the URL right up on the top. So when you take that URL and you run it into your little browser, in fact, that's the same URL that you're seeing up in here, nearly. Yeah, except it's got the statistics. KS means key statistics. He's able to go in and he says, aha, 0.63, and you go back to the Yahoo program and it says, yep, that's it, 0.63. And I can also do a computation for my little PEGI ratio. I can get my yield, I can figure out my growth rate, and in fact, one of the things that Kyle and I were discussing is if you have a growth rate that's sustained of 18%, you can use what's known as the rule of 72. And the rule of 72 says take 72 divided by the growth rate, and that's how long it takes in years before your company hits a double. So if this growth can be sustained, and that's a big if, then it should be the case that Apple will double in 4 years. Not bad, right? Plus, during that time, you're earning a dividend. So, you know, you're getting, well, perhaps an extra, what was it, $12 a share? Times 4 years, perhaps? $48 on top of the double in Apple. So now Apple is looking like a very undervalued company. Right? So how does all this work? It's giving us lots of interesting and wonderful information. How does it get it? Well, I'm really very glad you asked. The answer is, it ain't J-soup. Okay? At the time I wrote this, I didn't know J-soup. Now we all know about J-soup, and it's sounding like it's really the way to go. But the way I did it was quite a bit different. I used the HTML editor kit, and in fact I've written some papers on this topic. And so within the HTML editor kit, I'm able to do things. For example, some of the stuff I get is a little bit ad hoc. For example, here if it ends with a .b, that means it's a bulletin board stock. That's the thing that people do when they modify the symbol a little bit in order to be able to get a what's called unlisted stock symbol. So interestingly enough, there are many exchanges, right? There's the American Exchange, there's the New York Stock Exchange, there's the NASDAQ, the National Association of Security Dealers and Quotations, I think, something like that. So there's a whole bunch of different exchanges, and sometimes when a stock falls below $1 a share or fails to file when it's supposed to, it becomes what's known as delisted. Those delisted stocks end up in an area which some people call the bulletin board. They still trade, but they're delisted. And they could be perfectly fine stocks, perfectly fine companies, but they're not filing properly or they're too undervalued. And this happens sometimes because they're considered too high risk for the exchange to trade them. Sometimes they become what is known as very thinly traded. So when that happens and you see those little symbols in there that indicate it's a bulletin board stock, you have to do some replacements. And that's what I'm doing in here. Let's see now. What else does this do? I got my Yahoo summary data. Let's see. The goal of writing something like an HTML editor kit parser callback is to supply implementations for tag encounters. So when the parser encounters a tag, it has to know what to do, and you supply it with a method that handles that tag. And so what you have is a inversion of control design pattern. You're supplying the callback mechanism for the parser. So when the parser runs through the HTML and says, here's an end tag, what do you want to do? You can say, aha, let's dispatch on the different kinds of end tags. If it's the end tag for the end of a table data, and the table data that it contains is this kind of table data, then I want to do a certain thing with it. You know, that's how I do the parsing. It's very ad hoc. It's what you call a non-object oriented dispatch. So that makes things a little bit peculiar. How do you call it? Idiosyncratic? I don't know. So if I see a title, I have a special mechanism here where I can process the title. If I see table data, I want to execute the setters, and now you can see the long dispatch. And if he sees an item in the table that he can recognize, like the peg ratio, then he sets up the peg ratio. If he sees an item like forward PE ratio or average volume or average 10-day volume, he can go through and he can set each one of these things. That kind of a long dispatch is a pain to write. It's not a particularly pleasant thing to have to do this. And yet, I don't see a good way to avoid it, although I've been very clever about generating Java code automatically in the past. So if you put on your thinking caps and you say to yourself, gee, how many fields are there? 100, 200. Wow, I'll have to have 100 or 200 variables, 100 or 200 setters, and 100 or 200 little dispatches that say, if it's a this, then do that, and if it's a this, then do the other thing. And what a nuisance that'll be, because some of those things will require that I parse really wacky-looking numbers. Numbers that say things like 12.4b, where b is for billion, right? Or 4.5, you know, something like K, where K is for thousand in terms of numbers of shares, or M for millions, right? And they're very ad hoc with that, and there'll be commas in there, and there'll be all these other things in there, and it's going to be tough, right? Because you've got to try and do these parsing elements one thing at a time. Not particularly easy, but it's the only way in which you can, I would call it, add semantic meaning onto the data. That is, if you want structured data in your class, you're going to have to do the parsing at some point. Now, I've seen some people who came up with solutions where the parsing was actually in the data structure instead of in the parser. And when that happens, and it's correct, you get full credit. But you wrote remarkably poor code. Right? Why? Because what you want from a data structure is like a container of data. You don't want like your parser to be living there. So your parser may populate your data structure. It has a different role in your system. So if you can clearly identify the role of the parser as the thing that populates your data structure, and now you've got this data structure sitting over here getting all its setters set, then you don't really want parsers to co-locate with your data structure. You know, the parser has a data structure, or the parser uses a data structure, but the data structure doesn't have a parser in it. That doesn't make sense. So when you look at the Yahoo summary data, if you see it isn't really clean, like it's got replace strings in it or something like that, that's not particularly nice. Let's see if we can get the summary data out of here. Oh, here it is. I was looking for it. So now here's the summary data, and now we can sort of see it's got all of this stuff in it. And it's got all these setters in it. And it's got a mechanism for converting to a string. And what else? Just a bunch of setters and getters. There's a little computation in here. If somebody wants to get the Peggy, this does that computation. In theory, the Yahoo summary data, it's in a position to basically claim that it's just a pure data structure with very little parsing going on, if any, perhaps none. Perhaps none. And then at the end of the day, I use reflection to actually print all the members of the data structure and their values. How are you guys with reflection? You ever try and use reflection before? No? Never had it? Never heard of it? Need a lecture on it? Happy to do it. Happy to have a lecture on reflection. Let's see, where would I be if I were a lecturer in reflection? Probably be living under my, chapter 24. Oh, there we go. So, reflection's kind of an interesting way in which we can do meta-programming. Meta-programming is programming with programs. So it's a great way for us to be able to generate code at runtime. That is, write programs that write programs. It's a great way for programs to modify themselves. It's a great way to discover information about data structures that we might not want to hand code. Like if we want to print all the details of a data structure without having to print every single getter or every single setter. So reflection is a great way to automate and to work, I'll say, smarter instead of harder. Working smarter. So here's an interesting idea. If you have a string with a fully qualified class name, like java.util.date, that string contains a lot of information. It contains really the folder structure that holds the bytecodes that were output by the compiler. The top level folder is called Java, and then underneath there must be another folder called util, and then underneath there must be a file named date.class. And date.class would be the output of the Java compiler, that is some bytecodes, which were put there for the loader to find, so that at the runtime, if somebody makes reference to java.util.date, the loader will be able to find it because java.util.date will be in the class path. So the loader will then go out to the file structure and it'll say, somebody wants to make a new instance of a date. Let's go find it. It'll go and it'll use what's known as an instance of the class loader. The class loader uses a long path known as the class path, searches the file system, finds the date, loads the bytecodes, validates the bytecodes, and then starts to execute the bytecodes, just the way a standard computer architecture would in an instruction fetch, execute, decode, and store loop. So in effect, the Java virtual machine is attempting to simulate a CPU. That's what it is. It's a RISC machine. It's a reduced instruction set computer. It's a 32-bit RISC machine. That's what a Java virtual machine is. In fact, if you implement it as an interpreter, it only uses 48 kilobytes worth of ROM. That's read-only memory inside of your microprocessor. On the other hand, if you have a massive 2 megabyte just-in-time compiler, you can get execution speeds as fast as C or C++. Or so they say. And so now what we're going to do is we're going to take the class, which is a very unfortunate name for a class, but it's class with a capital C, and we're going to call for name. That's going to use the class loader, and it's going to proceed to make an instance of the class that corresponds to the java.util.date. So this is a very interesting idea, because what it's doing is dynamic runtime loading of the byte codes into the virtual machine. And then it gives us a reference which allows us to make, it's not an instance of a date, it's the actual class from which instances can be made. It's not a cookie, it's the cookie cutter. So what we now have is a mechanism by which we can make lots of new instances of dates using the class C, which corresponds to the java.util.date. Now, here comes an interesting question. What happens if somebody says, instead of java.util.date, they say, bleh, right? Bleh. Well, if you try to get the class for name on bleh, the computer's going to go bleh, and it's going to say class not found exception at runtime, because bleh is probably not the name of a proper class. So it's, how do you spell? Smart guy. You know that prior to the French Revolution, Marie Antoinette was told that the people were starving. And she said, let them eat cake. And within 6 months, they cut off her head. The moral of the story is nobody likes a wise guy. How do you spell that? So, off with his head. So, stuff you can discover about classes using reflection. Well, if a class subclasses another class, we can find out about that. If a class implements an interface, we can find out about that. If there's a whole chain of superclasses, we can go right up the chain until we get to the primordial parent java.lang.object class. We can find out all the classes in the tree. So that's pretty cool. Not only can we find out about those classes, but I've written wonderful graphic user interfaces that lets you draw the graphs and automatically place the nodes on the graphs so that you can actually see the tree at runtime using reflection. So that's kind of fun, actually. You can get all the methods, you can get all the fields. Not only that, you can make instances of all the classes, and you can invoke the methods. And you can invoke the methods by direct invocation of an instance of the method, or you can take a string and invoke that method that corresponds to that string without having to write a very long parser and command line interpreter. So you don't have to write, if somebody types open, then do the open thing. If somebody types invert, then do the invert thing. So using a reflection system, you can write a very complicated looking parser and command line interpreter automatically. And the only thing you have to do to add new commands is write new methods. And blammo, they'll be discovered by reflection. I've done this. It's fun. So, it means working smarter, not working harder, which is kind of cool. You can find out all about the visibility modifiers. Visibility modifiers, default, public, protected. Is that it? Oh, private. And you can also find out about the data types the methods return. And you can find out about the arguments for all of the methods that you like to invoke. So you can get the data types for everything. And what can you do with all this wonderful information, you ask? Or another way to put it, less politely, so what? Right? Well, if you're in the world of component software development, aka Java beans, you can take one of these little Java beans and you can make an automatic editor for the bean so that it can come up on the screen and allow you to alter the fields using a graphic user interface without having to write a lick of code. So that's kind of cool. That means sort of visual programming. And visual programming is the future, and it always will be. There's ways in which you can get accessors, right? Accessors, those are the things that are used to read values, so those are the getters. And also, is. So if something is a Boolean, you might say is visible. You can do things like, is deadbeat. I like that. Could be true or false on a customer. You can get all that information out. You can invoke mutators, which are really just going to be your setters. And so here comes someone using a toolkit. A toolkit is nothing more than a collection of related methods designed to be able to do so let's say, specific kind of task. You've heard about toolkits before. Graphic user interface has a toolkit. There's a toolkit I created called ReflectUtil. So it's just make a new instance of a class, pass it into ReflectUtil, and then ReflectUtil will say, let's get all the write names, which are going to be your mutators. Let's get all the read names. That's going to be your accessors. And in fact, what we can do is not just get all the names, we can get all the methods that correspond to the writers and all the methods that correspond to the readers. And by doing that, we can group those things together and do interesting and wonderful things. So, for example, if you think about it, this is pretty close to what the Java virtual machine has to do. You can find something with a main class, right, or a main method, and typically it has to have a specific signature for the purpose of invocation. And the Java virtual machine looks for this signature whenever you try to run a Java application. In other words, when you think about it, how does the Java virtual machine know where the main is? Right? Well, you say, well, here's a class, and I want you to invoke the main method on the class. Well, you're giving it a string on the command line. He has to use reflection to be able to load that string, and then he has to use reflection in order to be able to invoke that main method. Let me see if I can get a cursor. Yeah, the little box in here, that means there's an array coming in. So this is like some sort of a new array with a null body. And now I can get a whole bunch of mutators. Those are the writers. So I got the writers that are the mutators. I got the readers that are the accessors. Let's have a looky-loo and see what we can do. I think that sounds like a good thing to try, right? So we'll go to the book examples, and we'll go to, stop that, chapter 24. And here's something called payroll. What do you suppose that does? Payroll. So here's the payroll. It implements some serializable instance, which we know means that the class can be converted into an array of byte. It has the name, the shoe size, the name of the busy student, a value pi, a double, which is 100, color, which is red, payroll. And I can convert it to a string in order to be able to print out the value. And it looks like we have, there's a graphic user interface. There doesn't look like there's a main method in here. I don't see a main. Is there a main? Oh yeah, there's one. It tests the graphic user interface generator. Let's try something a little different. Let's see now. We got a main. Let's make a payroll. Payroll. Payroll P equals new payroll. Now, what will happen if we use sout control J enter and print out an instance of the payroll? What will that print? Any guess? Want a hint? there is the primordial overridden method called toString. And toString can be implemented in order to provide us with some sort of a reasonable string representation for the payroll. But I'm not seeing any invocation or shadowing of the toString method, so I'm going to guess it's going to print the reference, which means it's going to look like a hash code. Let's see if that's true. Oh no, he got something. So there must be a toString method in there somewhere. I just missed it. Find toString. Yep, there it is. There is a toString method. So the toString method, right, if you took that method and you changed it from toString to toString 2, ran it again, then you'd get your little hash tag. Right, there's the little sort of, I'll call it the address of the reference in heap, in the heap. The heap is just like some spare memory the virtual machine keeps around. So to override that behavior, you implement your own toString method. But suppose, for the sake of argument, you wanted to print the values without having to implement the toString method. Yeah, here's my main. I'm going to try and make the main a little bit more findable by pushing it to the bottom. So what I'll do, just for fun, is I will use reflection to print out the payroll. So now let's print payroll out using print utils dot print reflection payroll. Now print reflection knows nothing about payroll. Right? Print reflection can print anything with reflection, especially if it is implemented the serializable interface. So by using print reflection, it should be able to go into the instance of the class and give us all kinds of interesting and wonderful information about it. And sure enough, not only has he printed out every, the value of every accessor, he's also printed out the one thing I didn't print out before, which was the color. And he gave it a color value, RGB. And it did it automatically. Now, not to put too fine a point on it, suppose I went back up in here and I said, and here's a string that's private, and I've got my own little private string, and the value is, and what do we call it? Silly. Here's my silly string, and it's equal to, end quote, bleh, and that's how you spell it. Okay. So now if I run this, what could possibly happen? Oh, I didn't get my silly string. Why? Well, because silly string didn't have a getter. So I really want to encapsulate silly string. Isn't there a toy called silly string? Refactor, I think it's called encapsulate fields. Oh, there it is, encapsulate fields. And so what we'll do is we'll find silly string, that's here. We'll make a getter and a setter for silly, and we'll refactor. And now somewhere in the program there should be a getter and a setter, and there they are, right at the bottom. So now with the getter and the setter, if I print reflection, yep, there's my silly string at the bottom. So the silly string has come out without my having to modify the print reflection utility at all. How did I do it? Well, I used reflect util. I went through and got a method list, and then from the method list I got all the read methods and all the write methods. I don't know if I needed write methods for this. Then for each read method I went and did an invoke in order to be able to populate a value, and then I got not just the name of the method, I got the actual value. I took the sort of a little fast path in explaining this, but I think what's interesting about this is that if you're going through and using somebody else's tools, you kind of want to say, gee, how does that work? And you can say, okay, well, here's reflect utils. Let's look at it. I give you all the code. And then reflect utils isn't that long, but it's not, that simple either. It contains a method list, which is my own container of methods. It contains, I guess, a bunch of helper stuff that I find convenient. Like if you just want the constructors, it'll get you all the constructors. All the getter methods, public methods, you can get private methods. You can determine if it has a main. That's convenient, because then it can be qualified as an application that could be run. You can get all the super classes, super interfaces, too much stuff to learn, really. But it's nice to know where it is, and it's also nice to see it. When you want to get the read methods, what he's doing is he's determining if the method begins with a get or an is. So it goes through, looks at all the methods, and figures out the method name, and if it starts with get or is, it figures it's an accessor. So based on that pattern, that string pattern, he's able to proceed through the entire system with the read methods, the write methods, everything. So that's kind of cool. Works reasonably well. So now, with something like reflect utils in your pocket, you can proceed to do a whole bunch of interesting and wonderful things with reflection. It's not too idiosyncratic that I have my own toolkit, is it? I mean, I could write all that stuff from scratch every time, but why bother, right? So sometimes people think, oh, but I don't want to learn just Professor Lyon's toolkit because that's not the way real Java works. Well, I give you all the source code. You can use it or lose it. So I don't feel too bad about giving you the source code. I know you won't be using it for evil. You'll only use it for good, right? So you can do things in reflection. You can do sneaky things. You can do clever things. Let me tell you what you can do. If Sun, or Oracle nowadays, decides they don't want to give you a public method, they make it private, you can use bytecode engineering and turn it public again. You can modify stuff in places you shouldn't be able to modify. You can go where you shouldn't go and do things you shouldn't do. And so that's what you can do. It's a very popular way to go about doing the kinds of things you want to do that somebody said you shouldn't need to do that. And I hate to be told, oh, you shouldn't want that, or you don't need that. So I go in and I do what I want. And so it gives you a very powerful gun. And if you shoot yourself in the foot with it, don't come crying to me, because that's on you. You've been warned. If I want to, I can take a string and I can use that to invoke a method. And that's kind of cool. Let me show you a nice application for that. And the application is in image processing. Why not? If you're going to have an application, it might as well be in something. So here's a real-world application that uses reflection to build a command line interpreter with a minimal amount of effort. And it's in IP main. And if you run the IP main method, you get a nice little interface. And this is the command line interpreter built using reflection. And if you want to find the methods, I think you can type print methods, and it prints all the methods it has access to. And then if you type open, it invokes the open method if there was one. There isn't one? Really? Well, let's try something here. I'll open up an image. Let's see, here's an airplane. Now if I type in negate, good. Now if I type in SQRT and negate, there. And then I could type in fisheye and negate, and so now it's doing both. So what he's doing is he's taking the strings, finding the methods, and invoking them in turn. And he's doing this using reflection. So what this means to me, the image processing guy, is I don't have to worry about extending my parser. All I have to do is add a method for doing the image processing, and then I can just write my own little script for specialized kinds of processing. And you could say, yeah, well, I could have done the whole thing with menu items. But yeah, but then you would have had to like click around and look for the menu items. Sometimes having a parser is just convenient. And it's allowing me to combine different sorts of image processing operations in a relatively automatic way. And these will work with just about any image, I should think. Let's see if we can find one. Oh yes, here's Dr. Diffracto. That's scary. And now let's see what happens here. Yeah. And we'll do it again. Yeah. So it's all very weird. But there it is. Nice application for a command line interpreter. And this is what happens when you type in something and it can't find the method. It says no such method exception, or class not found at runtime. These are common reflection errors. Your compiler will not save you from this. If you start using strings in order to be able to get access to first-class references, and those references are being misspelled, you're sunk. Really. So, what I do is I try and catch those exceptions, like I did here, and then the program recovers and continues. I still print them out, though. Isn't reflection fun? Not so much? I'm not hearing a yes. So, yep, CNFE, what's that stand for? CNFE. Somebody typed in bleh, and they got CNFE. Now you know how it's spelled. It's class not found exception at runtime. CNFE. So that's typical. You got limits. This is the kind of thing that you're trying to map strings into classes. If you can't find the class, that's a bummer. It's going to throw an exception at runtime. Every object has been made from an instance of a class. Anytime you encounter any instance of anything in the Java virtual machine, you will be able to get the class from whence that instance came. That just sounded so weird. I don't know why. So here's a container of methods. I have my own little helper for that called the method list, and that'll allow me to get the reader methods and the writer methods. I can go and get the mutators and the accessors. And that leads me to one of the most advanced topics in the Java language, reasonably new anyways, called annotation, which really is all about reflection. Have you all tried annotation? You haven't? Annotation allows us to create contracts, specifications, and semantics for our instances. So if you said to me, well, gee, I want to be able to set x. It's a double. And I could say, okay, great. What does x represent? You could say, oh, it's temperature in degrees Kelvin. Say, okay, well, x probably shouldn't be going negative. But I know that because I know something about Kelvin, right? If you said to me, well, I want to set the angle, I'll say, okay, is the angle in degrees or in radians? Say, oh, I like degrees. Say, well, that's very important. We'll make it so that the range is from 0 to 360. If it was going to be radians, I might say it's from 0 to 2 pi. So knowing something about the range is kind of important, especially when you design the graphic user interface. You said to me, oh, I want to input a credit card number. I say, okay. Credit card numbers have how many digits? You say, let me look it up. 16. Can they be negative? No. Are they always integers? Yes. Okay, let's design an interface that takes that into account, right? Makes it type safe on input so that you're only inputting 16-digit credit card numbers. Annotation can do all of that. Annotation can give us a spec on the kind of data you expect and can even help us to build graphic user interfaces that ensure that the inputs are guarded. That is, when somebody asks you for an age, it's not going to be -10. And when somebody says, enter a credit card number, it's not going to be 3.141526, whatever. So it's one of those things where I want to have some kind of contract that enables me to know that the program is being used correctly. And it can't just be because somebody read the directions. It has to be enforced automatically, because nobody reads the directions. In fact, even fewer people actually write directions. So if you think about it, semantics give us the meaning, and syntax give us the grammar. And when we build a parser, we're usually thinking about grammar. We're not thinking about meaning. So with annotation, if what I can do is say, yeah, here's x, it's a double, I can answer questions using annotation, like, can it be negative? Can it be 0? What's the range on x? How can I know these things? And so what we'd like to do is build a way to put that stuff into our Java program. We want it to be geographically co-located with our setters and our getters, but we don't want it to have to take up a whole bunch of room in the compiler output, and we surely don't want it to slow down our computer. It shouldn't slow anything down. In other words, it shouldn't say, if x is less than this, then emit an error, range out of bounds exception at runtime, right? I don't want that, because that's going to make the whole program slow. So instead what we do is we devise a mechanism that has, a way for us to get information about the values. So you can, if you want, change what's called the retention policy for your annotation, which means if you don't want it to be available at compile time, it doesn't have to be, and it doesn't have to make your bytecodes bigger. But then it won't be available in general. If you do want it available at compile time, it'll be output in the bytecodes. So here's an interesting annotation, the Boolean range. You can make the default value true, and you can even get a name which does not necessarily correspond to the setter's name. You can use default values for colors. You can use default values for any one of a number of different variables, and you could even do it for reference data types. So that's kind of neat. These values, I don't know if you can tell, they're 24-bit values. This is red, that's green, and that's blue. And they're hexadecimal numbers that range between 0 and 255. And they're packed into these 24-bit quantities. And so you can take them 2 hexadecimal digits at a time. And that'll give you the red, green, and blue. Here's one. It's a double, and I'm giving you not only its value, the default value, but I'm also giving you the minimum, the maximum, the increment, which might be used for something called a spinner, which has a button that goes up and a button that goes down for changing the value, and a default name for this double precision number. And here's the example. And you can see the setter for y is actually a whole lot smaller than the annotation behind y. But the annotation contains a whole bunch of information, like the default value is 50, the minimum and max, it goes from 1 to 100, the name is hello world, it goes up by increments of 1. You could make it increments of 10 if you like. And keep in mind, this whole thing with the range does not have to be output in the byte codes. Here's an array of ranges with minimum and maximum for each one. It's homogeneous array, so they can all have the same min and max. And here's an example of the array with names, where each name is different. So that's kind of cool. Let's try an example here. We'll go back to payroll. And what we'll do is we'll automatically make a graphic user interface based on annotation. Let's see if that works. Isn't that cool? So now what we have is a property editing sheet which enables us to change the values. So here is somebody who used the term silly string, and they probably spelt it wrong. Maybe this is a correct way, and we'll say something like okay. And now, not only has he output the silly string, he's output it in XML. And here's the change, where the new value of the silly string has been changed and then output for us to see. Let's try a different color. Here's a nice color editor, came up automatically. And is there like an OK button in any of this? I think there would be, right? It's a real nice color editor. Oh, there is an OK button. There it is. Ah, and it changed in here. That's the actual value. And now if I click OK in here, he shows me the actual color values have been changed. If I go in and change his shoe size to 13, and click OK, now you can see 13's in there. If I go in and I say, what is the value for pi? And I say, well, let's just set pi to some wacky number. And there you can see it comes right out. And now what we'll do is, here's the spinner. And that gives me an interesting notion about model view control. This slider becomes a controller, but if I click on the up arrow in here, you can see the slider also becomes a view. So I can make this, I don't know, 79, hit enter, and the slider pops to 79. If I click up, it's going up by increments of 1, but I can change those increments and make it go up or down by increments of 0.1. I can use my little up arrow or my down arrow to get fine motion control, and I can use page up or page down to oh, no, I can't. Should have done. No, page up, page down. It's not working. Okay, life in the big city. Oh, it's the up arrow and the down arrow on my little laptop. Let's see if we can enter this. Enter, and now click. Oh, you know what? It goes out of range. If your increment's 100 and then you try to increment up once, that won't work because you are governed by the semantic annotation to be between 1 and 100. So you try and enter in a number like 178 and you hit enter, it won't take it. It won't go to 178 because that's out of bounds. It's out of range. But it'll go there. That'll work fine. So it's guarding the input. Ain't it cool? Guarding the input using annotation. So let's see what we got here. So here's my little editor. The run annotation editor takes an arbitrary instance coming in, builds you a nice editor with a property sheet and a graphic user interface using swing in order to be able to alter values. And with that technique, you no longer have to worry about things like doing any GUI programming, assuming you like the default property sheets. You know, if they're good enough for you and for quick prototyping, in general, I think they are, then this will work for you. But there's the discipline that you have to have. You have to tell, you know, you have to tell the program what the ranges are for things like the shoe size, what the default values are, things like that. So if it doesn't know that, it can't construct a proper graphic user interface for you. So that's key. But at some level, that's important documentation. It's good to know minimum and maximum shoe size for your business logic. That's good stuff. And what you saw with the up arrow that changed the value continuously when I held down the up key or the down key, that is a spinner. Is it break time? I'm feeling it's break time because it's like we've been at it for an hour. So take a 5-minute break. Thank you.